So I just recorded you guys a beautiful video, and the microphone was on mute the whole time. So this is my second go around with this. Hopefully that makes it a better lecture. So today we're going to talk about making perfect square trinomials. We're going to talk about signs. And we're going to talk about odd numbered middle terms. So first we'll talk about signs, and we will look at x squared plus 8x plus c, and then in pink we will look at x squared minus 8x plus c. And I typed out the steps so that you guys don't have to watch me write them. I'm sorry that I didn't think about doing that until the end of May, but so be it. So for the red trinomial, the middle term is positive 8. For the pink trinomial, the middle term is negative 8. So we need to divide it by 2. So we have positive 8 divided by 2 is positive 4. That's supposed to be a 4. And then we have negative 8 divided by 2 is negative 4. So then with the red trinomial, we square our middle term. We have positive 4 squared. We get 16. And with the pink trinomial, we have negative 4 squared. And you guys can see where this is going. Is also positive 16. So it doesn't matter if your middle term is positive or negative. The math to do it is the same. So you can pretty much just ignore the signs. Take the middle term. So if I were ignoring the signs, it would look like this. Take the middle term, just take 8, divide it by 2, square it. That's supposed to be a 4. Okay, so with the red trinomial, we get x squared plus 8x plus 16. And with the pink trinomial, we get x squared minus 8x plus 16. And they're both positive 16 because a positive number squared is a positive and a negative number squared is a positive. So that takes care of signs. So now we're going to look at odd middle terms. Let's look at x squared plus 5x plus c. So we need to take the middle term, and we're not looking at the signs, and we're not taking the variable into account. We're just taking that coefficient, the 5. And we're going to divide it by 2. So you can divide it by 2 and get 2.5. Or if you take 5 and divide it by 2, you get 5 halves. And you're going to be tempted, in your brain, decimals are easier, but not really. You're going to be tempted to use the 2.5, but it's not easier to square it, 2.5. If you don't know 25 squared off the top of your head, then you have to do this, because you'll be solving these equations without a calculator for like SATs and stuff. So 5 times 5 is carry the 2, 5 times 2 is 10, 11, 12, 2 times 5 is 10, carry the 1, 5, 6, 25, move the decimal twice, 6.25. Or you can just square 5 halves and quickly get 25 fourths. So already we see that the fraction's easier. It's just easier to square. Similarly, later on down the road, when we're going to be factoring these, x squared plus 5x plus 6.25 versus x squared plus 5x plus 25 fourths. The 25 fourths one is a lot easier to factor because it's the square root of the first, the sine of the middle, the square root of the last. And the square root of 25/4 is a lot easier to do than the square root of 6.25. Even though we know right now that it's 2.5, they're gonna, well, when you'll always know that, but this is going to be, the 25/4 is just a lot easier to take the square root of. So let's do one. I'm going to give you one, then I'm going to ask you to pause and try it, and then I'll do it out for you. Would you please, x squared plus 9x. Actually, I think we're going to do x squared plus 7x, because I think you have a 9 in one of your practice problems. X squared plus 7x plus c. Go ahead and find the value of c that makes the trinomial a perfect square. So pause. I'm going to keep going. We got the middle term. We're going to divide it by 2, and then we're going to square it. 49/4. So x squared plus 7x plus 49/4 is a perfect square trinomial.